In this video, we are going to talk about trigonometric ratios. Here we have a triangle which we name as A, B and C, where angle B is 90 degrees. We have three sides AB, AC and BC. Usually we write the sides as AB, AC or BC, but we can also write these sides in small letters like this. The side opposite to angle A is named as small a, and the side opposite to angle B is named small b, and the side opposite to angle C is named small c. With these three sides, taking two at a time, we have certain ratios. Like it could be AB to AC. I can have ratios like BC to AC or AB to BC. I can also have the reciprocals of these three, which is AC to AB. Reciprocal of this is AC to BC, and reciprocal of this is BC to AB. So I have 6 ratios here with the three sides of a right angle triangle. So I can also write them in terms of small a's, b's and c's. AB is C and AC is B, therefore this is C over B, and this will be A over B, and this will be C over A, and so on. This is B over C, and this is B over A, and this is A over C. So these 6 ratios of the sides of a right angle triangle are called trigonometric ratios. If we take the same triangle again and then extend it on all the three sides like this. In these triangles rather, I am keeping this angle constant but extending the sides of the triangle, this and this. So in this case, all the three angles of the triangle of these three triangles are the same, this being 90 degrees in each and this being the common angle. Hence, these angles of the three triangles are the same. So, they are equal. Therefore, all the three triangles have all three angles equal. Therefore, they are similar. In the previous case, we had this as A, this as B, and this was C. Therefore, we called this as small c, this as small b, and this as small a. We had 6 different ratios with this A, B and C. We can also extend the same thing with the next triangle, say for example A1, B1 and C. So if we call this as C1 and this as B1 and this as A1, then we have other 6 ratios with A1, C1 and B1. Similarly, I can call this as C2 and this as B2 if I call this as A2 and B2 triangle. Therefore, this side length will be C2 and the length A2C will be B2 and this will be A2. If I consider the triangles ABC, A1B1C and A2B2C, which are all similar, and write the ratios of similar sides, then I will be getting in triangle ABC, the ratios are A over B, A over C, C over B and etc. In triangles A1, B1, C, the ratios are A1 to B1, A1 to C1, C1 to B1, etc. Because the sides are A1, B1 and C1. And in triangle A2, B2, C, the ratios will be A2 to B2, A2 to C2, etc. So these are the ratios in each triangle. Now that they are similar, the ratios will be equal like this. The corresponding sides A over B will be equal to A1 over B1 and it will be equal to A2 over B2. One more ratio, I'll write it here. C over B will be the same as C1 over B1 will be the same as C2 over B2 and so on. Therefore, the all 6 trigonometric ratios will be equal in all these 3 triangles. As long as the angles of the triangles are the same, the ratios of their corresponding sides remain the same. This means that for a particular angle, the ratios of the sides of the triangle will be the same. Now let's again consider the same triangle. You must have noticed that the angle A is in a different color. That means I'm going to consider this angle now. If you consider this angle, which is angle A, and this side BC is opposite to the angle A, therefore this is opposite to angle A. And this is touching the angle, therefore this we call it as adjacent to angle A. And this AC is always the hypotenuse because it is opposite to 90 degrees. So this is how we name the sides of a right angle triangle when a particular angle is considered. This angle should not be the 90 degree. This angle should be either A or C. We can also see what happens if C is considered. If C is considered, then this side becomes opposite to angle C because this is just opposite to the angle C, and this side becomes adjacent to angle C. And this is always hypotenuse opposite to the 90 degrees of the triangle. In the triangle when angle A was considered, BC was opposite to A and AB was adjacent to A. So I'll write it as adjacent to A and opposite to A. Whereas the same BC was adjacent to C and AB was opposite to A. Therefore, if you write the ratio, say for example, AB over BC, then if you are considering angle A, then you should be writing as adjacent to A over opposite to A. But if you are considering angle C, then you should be writing it, the same AB over BC will be written as opposite to C. Sorry, this is C. Opposite to C over adjacent to C. Therefore, this ratio depends on the angle. The name is different, as you can see, adjacent over opposite when A is considered, whereas opposite over adjacent when C is considered. Generally speaking, in a triangle we have 3 sides in this name. The one which is opposite to the right angle is hypotenuse. One of the other 2 sides will be opposite and the other will be adjacent. So we have 3 names given to the sides of a right angle triangle: adjacent, opposite, hypotenuse. The adjacent and opposite sides may change depending upon the angle we are considering. This opposite is when we consider this angle. But generally there are 3 sides, and therefore the ratio, 6 ratios which we have already seen, can be written in these forms, like opposite over hypotenuse, that is this side to this side, and then I can also have adjacent to hypotenuse. This is the second ratio. I can have opposite to adjacent, the first 3 ratios, and I can have their reciprocals as the next set of 3 ratios: hypotenuse to opposite, and the reciprocal of this will be hypotenuse to adjacent, and the reciprocal of this will be adjacent to opposite. Opposite to hypotenuse is always named as sine ratio. Adjacent to hypotenuse is given the name cosine ratio. Opposite to adjacent, we call it as tangent, and the reciprocals of sine will be cosecant, and the reciprocal of cosine will be secant, and the reciprocal of tangent is called cotangent. But we don't write every time in this big names. We have short names for this. This is shortened as sin, which is not sin but it is sine. This is cos, and this is tan. This is cosecant. Sometimes it is written as cosec, or CSC. Either way is right. This is secant ACC, and this is cotangent, which is cot in short. So these are the names given to the 6 ratios of a right angle triangle. We have sine, cosine, tangent, cosecant, secant, and cotangent. But now when we consider angles A and B and C, B is a 90 degree always, and then so we have two options of considering either A or C. When we consider angle A, adjacent to hypotenuse will be AB to AC. So AB to AC will be adjacent to hypotenuse when angle A is considered. The same AB to AC will be when the C is considered. This is opposite, this is adjacent, and this is hypotenuse. When angle C is considered, AB over AC becomes opposite to hypotenuse with the angle C. Therefore, if we find out what is the name given for adjacent to hypotenuse, we can find it over here, which is cosine. Therefore, this is cos, but the angle mentioned here is A. Therefore, this is cos A. Whereas when the angle C was considered, it was opposite to hypotenuse. Opposite to hypotenuse is sine. Therefore, this becomes sine of the angle C. The same ratio AB over AC is either cos A or sine C. Similarly, the other ratios can be written. What about BC over AC? BC over AC when angle A is considered is opposite to hypotenuse when angle A is considered. Opposite to hypotenuse, as we have already seen, is sine. Now the angle considered is A, therefore it is sine A. BC over AC when angle C is considered will be adjacent to hypotenuse. Therefore it is cos C. So the ratio BC to AC is either sine A or cos C. We can continue in the same way with all the other 6 ratios. What we have seen here is, we can see that cos A will be the same as sine C, and sine A will be the same as cos C. What happens to the tan? The ratio AB to BC will be, when angle A is considered, we have AB is adjacent and BC is opposite. Therefore, we have adjacent to opposite is here, which is cotangent, which in short we call it as cot, and the angle considered is A. The same thing is also written as, in terms of angle C, AB is opposite and BC is adjacent with respect to C. Therefore, opposite to adjacent, which is here, which is the tan. Therefore, opposite to adjacent of C is tan C. Therefore, AB over BC is the same as cot A and tan C. Hence, we can write it here, cot A is the same as tan C.